Hey everyone, welcome back to my daily coding series. Today is day 57. I'm going to look at car fleet today. This is the last stack problem that I'm going to try. And so far the stack problems have really been pretty tricky for me, at least the last two. So let's see if car fleet is any different. Alright, so I have not read this problem before. So let's take a look. Alright, there are n cars traveling in the same destination to the same destination on a one-lane highway. You are given two arrays of integers, position and speed, both of length n. Okay, so positions and speeds of every car, of the ith car, and miles per hour. The destination is at a position, target, miles, okay? A car cannot pass another car ahead of it. It can only catch up to one car and then drive the same speed. A car fleet is a non-empty set of cars driving at the same position and same speed. A single car is also considered a car fleet. Okay, so we're going to be looking at these positions and speeds and grouping them into fleets. A car fleet is a non-empty set of cars driving at the same position. If a car catches up, then the car is considered. Okay, so the first thing that comes to mind for me is like just a simple line formula. Y equals mx plus b. So, and I don't know what this will have to do with the stack, but I'm just going to talk it out. So for instance, car 1 has a position of 1 and a speed of 3. So position 1, speed is 3. And car 2, handwriting's not that good today. All right, car 2 is position 4, speed 2, and the target is 10. So you can represent these as equations where the position is the y-intercept and then the speed is the slope. So you could say for this car, y equals 3x plus 1, so 3x plus 1. And then this equals y equals, so where y is miles and x is 1 mile. 1 hour. X is hours and y is miles. Okay. So y equals 2x plus 4. So we're essentially asking the question, do these 2 points intersect before 10? So I would see when they intersect by making them equal to each other. And we get x equals 3. So they will intersect at 3 hours. So what will the values be at 3? It'll be 10. So 10 equals 10. So maybe what you could do is have this equation, and then you would just check. You could honestly maybe just do a binary search and figure out which x. The question is, does there exist an x before target where they intercept? And if they do, then it's part of the same fleet. The only problem with this method is once we start adding new cars, we can't really use the equation because, for instance, once this intersect, let's say the target was 20. Once this car intersects with this at 3 hours at mile 10, this will now get changed to like 2x plus 1. Because it can only move the speed of the minimum. So then if these caught up to something else going 1 mile per hour, then they would all change to 1 mile per hour and they would all be at the same position. So they would just become one fleet. So we could honestly just like join them together. So when 2 intersect, so if we have like 3x plus 1 equals 2x plus 4. So when they intersect at time equals 3, we can merge them into just one fleet. So so we went from 2 fleets to 1. So we can actually start with position many fleets. So we'll start like with 2 fleets, and then we can calculate every step and then see if any of them intersect. They become 1 fleet, and now that fleet moves at the same speed and same position. We don't need to know that there are 2 cars in a fleet. We don't need to know that. We just have to return how many fleets. All right, so this is a starting point. So using that logic, I'm sure I'll have to make modifications to it, but so let's look at another example. So we have 4, 1, 0, 7. So I'm looking at this example down here now, and 2, 2, 1, 1, and target equals 10. Okay, so let's just remember these are the cars like that. So our first car is, and then this is position, and this is speed. So our first car is y equals 2x plus 4. Then we have y equals 2x plus 1. Then we have y equals, so if this is 1, 2, 3, 4, 1, 2, 3, 4. Not muted. Okay, so then 3 is just x. Yep, just x. So it'd be 1x plus 0. And then 4 is x, y equals x plus 7. Okay, so I noticed something. Yeah. So this one starts ahead, and these two are faster than it. So intuitively, I would say that there's 2 fleets. So these 3 would become a fleet, and then this one would be its own fleet. So, okay, the answer is 3. All right. So my question is, wouldn't these intersect? Maybe not quick enough. Yeah, maybe not quick enough because the target's only 10. So at time 3, so when x equals 3, this is already 10. And when x equals 3, this is only 7. Okay. So maybe what we could do is like have a position array, and every time we could update each position by its speed value. So at t equals 0, so like x equals 0, I guess. When x equals 0, the positions are 4, 1, 0, 7. When x equals 1, it becomes, so this goes up by 2, so it becomes 6, 3, 6, 3, 1, and 8. X equals 2. We have, so it goes up by the same amount, so we have 8. 5, 6, 9. So nothing is caught up to each other yet. And then we have x equals 3. So now it's 10. So 10, 7, 7. 10. Yeah, so it would be 10, 7, 7, 10. So why is there not 2 fleets? Yeah, okay, so the cars 4 and 7 become a fleet. That looks correct. The cars starting at 1 and 0 never catch up to the car ahead of them. Maybe we have to keep going. But they're at the same position though. So why are they not considered a fleet? 0, 1. Why'd I go to 6? I don't think I was supposed to go to 6. I went from 1 to 6. That doesn't look right. All right, so this should be 2 and then 3. Okay, this makes more sense now. So yeah, the tricky part though is like if this is like if we kept going, we'd have to know. So we'd have to like have speeds and then update the speed to be like the minimum of the two. So like once these two, okay, so like, hey, this one became 10 and this one became 10. So instead of you increasing by 2 like we were, now you're going to increase by the minimum of the two that met up. Yeah, you're going to increase to the minimum. And then, so how do we know when, do we have to keep going until everything is at 10? Like what's our stop condition? Because then we could say x equals 4 and then we could have, you know, so we could keep going and this could go 9 and then 11 and this would go 4, 5, all the way to 10. Yeah, so I think we would just go to till everything is at the target position. So that's my initial idea. It doesn't use a stack at all, but my initial idea would be, so keep track of current position and current speed. And whenever anything becomes like the same fleet, so we need to detect, so we need to detect when two cars become in the same fleet, and then we need to adjust the, so how would we do that? Well, one useful trick, I guess, is we know that cars with lower speeds can never like catch up to something with a higher speed. So it has to be that the higher speed goes to a lower speed for sure, but I don't know if that really helps. We could calculate also where it will be at, or like what value is needed to get to 10. So we would say like target equals 2x plus 4. And then in this case, it would be 3. And then 10 equals 2x plus 1. So that's 4.5. 10 equals x, so that's 10. And then we have 10 equals x plus 7, so that's 3. So these are all the times. Yeah, that makes sense. So these are all the times that they'll reach target if they just go. But like I said, it's not, I don't know if we can do it that way because it's possible that they might catch up with a slower fleet sooner than that. So I'm going to start just by printing out but at every step, if we want to keep track of the positions, we would have to, so it would be like t times the length of like the number of cars. So I'm just going to try doing it this way first. Yeah, I wish there was a way I could just like I don't know if it's called vectorizing them, but just add like 4 to 2, 1 to, but I could probably do that with list comprehension. All right. So we'll start with the position, And then we want to say while, so I'll have like a time stamp set to 0, while t, well, we're not really stopping based on t. I guess we could say while, so I'll have, I'll update position, I guess. So while the minimum of positions is greater than target, we want to apply, so we'll say positions equals I, so positions of I plus speed of I for I in range. I guess I could just say 4. That's how it goes for I in range, length of positions. So I'm assuming that positions and speed will always have the same strength. Or same length, sorry. Alright, so positions here will always be, and can speed be negative? No. But if speed is 0, then this will be an infinite loop, I believe. I'll just say if 0 in speed for now, just return. Okay. I'm not printing anything, but position. Okay. I think I wanted to say, well, it's less than target. All right, so if we look at, let's just take it simple now. Okay, so we have 1, 4, and the speeds are 3, 2. So this goes, so time equals 0, time equals 1. So when time equals 1, it goes to 4, 6. Time equals 2, it goes to 7, 8. And when time equals 3, it goes to 10, 10. Yeah, so I'm sure if I printed position right here, it would reflect that. Yeah, so it shows that. So what do we need to know? Well, let's say position of I equals position of I plus speed of I. But we have to know the fleet. So we have to know what's the next biggest thing. So this is just like the last problem. So we're going to go up to the speed, unless now its position is... So we need to check. So if we have 1, 2 as positions and the speed is, so let's say at time equals 0, we have positions 1, 2, and the speed is 5, 5, 1. Our expected behavior should be that this goes to 3, 3, right? So, so to define first the expected behavior, I would expect in this case that, so you would try to move this by 5. So you'd have to store like that this one is behind this one. So maybe you could have like fleet ID. So you can have like fleet IDs. So you'd have, so like fleet 1 would be the biggest. So here you'd have fleet 2 and fleet 1. Actually, let's just say fleet 1 is in the back. So you'd have 1 and 2 for your fleet IDs. And even if this, let's say this was 1 and 3, just so it's less confusing. So our positions are 1 and 3. So positions is 1 and 3. And then like our fleets, we'll start off as fleet 1 and fleet 2. Okay. So we will add 5 to our fleet, which is 6. Then we'll add 1 to our fleet, which is 4. And then we'll check, is the fleet order preserved? Like, is fleet 2 still ahead of fleet 1? And if it's not, then we can change fleet 1 to be equal to the speed of fleet 2 and the position of fleet 2. And then we would just have, or maybe what we could do is just delete, like just, ignore it from here on out. We don't need it. So they combined into one fleet. So we could do that. So whenever something passes a fleet, then you just delete the one that passed it. So let's try that with a more complicated example. So 4107 and 2211. So but I don't really like this one because they, alright, let's just say for this one target equals 15, I guess. Okay, so we'll have 4, so our fleet IDs will be, so this is, if 1 is the smallest, this will be fleet 3, fleet 2, fleet 1, and fleet 4. So they start out at 4 different fleets. The positions at time equals 0 is 4107. And then the speeds are right here. So at time equals 1, we'll have 6. And we can't really check anything yet because there's nothing else. We can have 1. So 1 plus 2 is 3. So what we want to check is, did this pass fleet 1, the lower fleets? Did this pass the lower fleet? Right, because it can never, well, I guess did it pass a higher fleet? Yeah, we'll check. So did this pass fleet 3 or fleet 4? No. Well, fleet 4 isn't, well, maybe we should do it in we'll start with the highest fleet then. So fleet 4, because this can only be passed, it cannot pass. So fleet 4 will become position 8. Fleet 3 will become position 6. So now this is going to check, did I pass fleet 4? No. Okay. Now fleet 2 is going to go to 3, and it's going to check, did I pass fleet 3? Did I pass fleet 3? No. And maybe this is where we use the stack, because it could, let's say, if it passed fleet 3, we want to check, did it also pass fleet 4? Which I don't, because we would make this fleet 3, I guess. Okay. So nothing happened. This will go to 1. Did I pass fleet 2? No. Okay, so we'll do the same thing, and I don't think anything gets passed, so I'll just fill it in. 5, 2, and 9. And then we have 10, 10. Well, let's start here. So this one will go to 10. And now this one will go to 10. And it says, oh, I'm equal to fleet 4. So let's, I guess, delete the higher fleet and give this one the speed of the higher fleet. So now now fleet 3 has a speed of 1. So it's same thing. Basically, we just need to homogenize them. Okay. So now one of our fleets has been combined, and then however many we have at the end will be our answer. So 10. Our next fleet is 7, and this one is 3. And now we don't have to calculate that anymore, so we can do 12, 9, 4. And then this would just keep going. They'll never pass until we get, I guess, t equals 10. Actually, wait. I did that last step wrong. So this now actually has a speed of 1. So it'll go to 11. This will go to 9. This will go to 4. Then we'll go fleet 3 goes to 12 at t equals 5. Fleet 2 goes to 10. This goes to 5. T equals, that's a 5, 6. This goes to 13. This goes to 12. This goes to 6. T equals 7. This goes to 14. We don't have to check because it's the biggest fleet. This goes to 14. We do have to check, and we see that it is actually equal to or greater than fleet 3. So what we're going to do now is delete fleet 3 and make this speed equal to whatever fleet 3 speed was, which is 1. And then this goes to 7. And we'd keep going. These both have a speed of 1, so they'll never catch up. So that's another exit condition if everything has the same speed, or if fleet, if everything has the same speed, or if the lower fleets have a lower speed. So then at time equals 15, this example would actually go to 2, because eventually this fleet would catch up. Okay, so I like this answer. The problem is I don't think it's right because A, it doesn't use a stack, and this is a stack problem. And B, I would have to figure out what data structure best implements this. So I'm wondering if we could use like a dictionary that maps the fleet to its position. Or maybe we could. So first of all, we have to convert these into fleets. And that could also be tricky if we have like 1, 1, 5, 4, for instance. So I guess what I would do is maybe you can like just sort it. Um, so I have to convert the positions into like their relative rank. So how you could do that is I suppose you could sort it. And then just like yeah, all right. So I'll just say this isn't exactly, so I think I'm just going to sort them like this. So we want our highest fleet. So we'll have like 1, so 0. So our slowest fleet should be the lowest number. So we'd have 7, 4, 1, 0. And then this would be fleet 1, fleet 2, fleet 3, fleet 4. So I'm going to say sorted position will be our stack. And then that will make it, for instance, 0. Maybe I can say reversed equals true. I think that works. So then we would get 7, 7, 0. No, 7, 4, 1, 0. So let me just print stack and see what that looks like. Reversed, is it reverse? It doesn't seem to be printing anything here. Seven, 4. Okay, so it is reverse equals true. Okay, so now what I want to do is have I'll say fleets, which is a list. And then I'll say, and maybe we can change it from a list later to like a dictionary maybe. So now I can say fleets of I equals stack dot pop. Well, we need to know how many times we pop it. So we could say while stack I equals 0. We can say stack dot pop. Wait, this doesn't make any sense. Because I need the indices. I could. Hold on, so I'm thinking maybe I could pop it and then based on the index. All right, so let's try that. So stack, I'm trying to append tuples. Okay, because I'm not, yeah. All right. That doesn't look like what I want. So it's 4, position of I. Okay, 7, 3, 4, 0, 1, 1, 0, 2. Okay, so now I want it to be just these numbers, 3, 0, 1, 2. 3, 0, 1, 2. That's what I want, right? Well, Well, now it's like, okay, I want to... So I want a 3 here, a 2 here. No, I want a 1 at position 2. I want a 2. All right, I don't think we should reverse it. Okay, I'm getting there. I don't know if this is even useful, but I think it could be. So yeah, I want a 1 at position 0, or sorry, at position 2. I want a, so this gives us the order. So now I'm going to say while stack dot pop, and that will give us the value in the index. So then we'll say fleets of I equals, so 0, for instance, should be equal to position, no, we'll say fleets of index should be equal to I. So in this case, fleets of 2 should be equal to 1. So if we look at fleets, it doesn't, there's a return statement there. Okay. Yeah, fleets will be equal to 0 times. Okay, so I have 2, 3, 4, 1. So I think it's backwards. I want my biggest fleet to be the slowest. So instead of it equaling I would like it to equal length of fleets minus I. I don't think it's needed, but that's just the way I designed it initially. So fleets, yeah, so plus 1. Okay, so this is now what I have. So it's the smallest is 1. I guess I don't really need the plus 1 now I think about it. Okay, so the smallest is 1. So 0 is the smallest, so we give it fleet 0. 1 is the second smallest, so we give it fleet 1. The only problem with this is we have to make sure that we aren't popping, like, all right, so previous would be equal to -1. And then if we want to say only if previous does not equal value. So I think that would make it so it only does the unique ones. So if I gave it, so if I said position equals, let's say 1, 1, 2, 3, or let's say 1, 1, 4, 3, I should expect to get 0, 0, 2, 1. So I got 0, 1, 2, 3. So if I even get this fleets array, is it going to be easy? And also, let me not worry about this edge case for now. Let's assume that there's no duplicates for now. So even if I get this fleets array, is the rest of the problem easy? I mean, it's solvable, I'd say. It just doesn't, this feels like not, this just doesn't feel right. Okay, so I'll just have it like this, I guess. And then If speed equals 0, what am I going to do? I guess I could also assume, alright, so I'm just going to say assumptions. Current assumptions. No duplicates and no 0 speed. So like these are things that I am not coding for yet. Okay, generate fleets. This helps us generate fleets. Okay, alright, so what do we want to do? So we want to start with the biggest fleet. So we'll say, okay, so fleet 0, or fleet 4, the max of fleet should go up by its speed. So I think what we should do is map the fleet to the index. Is that what we're doing already? So fleet tells us, so if I run it, alright, if I run it, what is fleet? Am I printing it? So fleets, these are both 1. That doesn't make any sense. They're all 3. What happened? What happened? Huh. It was working before. Oh, I has to go up by 1. Okay. So, alright, so it's telling me that position 0, so we're already mapping the index. So position 3. So I almost want it the other way around. I'm going to make it a dictionary. So it's going to point to the index. And we'll say, let's see what this looks like. So they're all -1s. That doesn't look good. Fleets. How did that happen? Fleets of index. How does that evaluate to -1? Length of fleets. Oh, I see. Length of position. So 3 goes to 3, 0 goes to 2, 1 goes to 1, 2 goes to 0. So this just tells me that zero is the second fleet. 1 is the first fleet. 2 is the 0th fleet. Okay, I want it the other way around, I think. So the fleets of like position of I should be equal to fleets of index. Right? Is that what I want? So, because I need to know where is the biggest fleet located. So I don't know. So the only difference is 0, 2, and 2, 0. So 0, is the 0th fleet located at position 2? Yes. The second fleet is, actually, I think it's good how it is. Okay, so what we're going to do now is, so we'll get the biggest fleet. So in length of position, and we'll go backwards. So fleets of I will give us the position of the biggest index. So we're going to say this equals speed. Gives me an index. So I want positions of fleets of I. So positions of, and this would be 3, should be equal to its corresponding speed. So speed of I would be 3, but I want it, what do I want? I think I want fleets of I like that. Yeah, so this will give me 4, 3, 2, 1. So the key is where the fleet is located. So fleet 3 is located at, I think this looks good. Fleet 3 is located at position 3. So we're saying fleets of 3, which is 3. Yeah, so positions of 3 should go up by speed of 3. And then we want to check, did this surpass? So like, so we'll say, so what is fleets of I? Index of fleet, or fleet, yep, index of fleet index, okay. So if positions of fleet index is greater than positions of fleets of I plus 1, so the bigger fleet, if it's greater than the bigger fleet, then we'll print fleet I past fleet I plus 1. This will give me an error. So if I equals length of position minus 1. I don't know if we need this anymore. We probably do, actually. Okay, let's see if this prints anything. Positions. Position. Alright, so fleet 2 past fleet 3, is that true? So it keeps being true. Okay, so in the case that it is true, so fleet 2, if I go back to my drawing board, fleet 2 is this one. Well, wait, fleet 2 is actually fleet, yeah, because I 0 indexed it, so it's really 0, 1, 2, 3. So we're saying that this row passed this row, which is true at time equals 3. So that's good. So in this case, what we want to say is we're going to delete, well, first of all, so we're going to delete, well, I guess, do we have to delete it? Well, it should be the length of, I don't know if it's going to let me do this. Maybe change to while loop because I'm deleting. So what I want to do is delete this one that we passed just to keep the numbers in order. So we would delete fleets of I plus 1. But we also need to update. So this has to now become that fleet. Or what we could do is just delete this one, but bring this number down by 1. I'm not going to do that. All right, so position of fleet index equals position of fleets of I plus 1. So we're going to make its position equal to the smaller one, and then we're going to make its speed equal to the smaller one as well. Equals speed of, is that what it's called? Speed? Yeah. Of fleets I plus 1, like that. So this might get mad, or does it not? Key error 3. That makes a lot of sense. Still key error. Fleets index, this one right here. Yeah. So we're deleting it. Let me get rid of this for now. Let me make sure. So I should be going 3, 2, 1, 0. Yeah, so that's all of our fleets. So yeah, so here it gets deleted. So let me try length of fleets instead. Okay, great. I think that's working as intended. So we can just ignore. So let me print fleets at the end. Oh. It's still updating it, which it probably shouldn't. Unexpected indent. So I think fleets will... Yeah, fleets only has 2 at the end. But it is weird. So this stops going up at all. Alright, so this one stops, this one stops. So I guess we just never update it at that point, which is fine. So then we just have these. So could I just return the length of fleets? My output is 2. Oh, do I need equal then? Okay, so this one works. This one... So if anything is greater than 10, so it's the stop condition. So this keeps going, so the other ones keep going. So I think if anything just becomes greater than 10, then we're not interested in it anymore. So I think what we should say is how could we just how can we trim that out? So if something is greater than 10, we don't want it to count towards anything. So could we set its fleet ID to like -1 or something? So we want to do this for sure. But what if they join up at 11? Yeah, so there's some tricks for sure. I'll be right back. All right, sorry about that. I'm back. So the question was, how can we basically just remove or not consider something that passes our target? So we could say maybe something like if position of fleet index is greater than target, we set it equal to target. So if it becomes greater than 10, we don't care about any intersections that have to happen after 10. We only care at 10. But we also need to make sure that if something passes it later, our code doesn't consider it. So, okay, so I'll just run this and see what that looks like. So yeah, we can see that everything's passing everything. So we need to make sure that this doesn't count. So I guess we could say like finished, which is equal to false times length of position. And then we can say finished of fleet index equals true. And then we have to make sure if it's greater than this, we'll say if position of fleets I plus 1 equals true, then we can just continue and not do any of this. So it says that these two finish and these two don't. All right, so let's see where it starts messing up here. So 3, 2, 1, 0, 3, 2, 1, 0. Why is it like only sometimes printing? So, sorry, let me just silence my phone. All right, so it's only sometimes printing. So fleet 2 passes fleet 3, and that's 2 and 3. So this looks good. Here it goes, oh, because I'm printing it every I. Yeah, so 3 gets skipped. Okay. So 0, so that one goes. Fleet 3 passes fleet. So I also want to say here, I'll print just finished. So I goes up, so fleet 1 goes up, fleet 0 goes up. So now I is 2 because we deleted deleted fleets I plus 1 from fleets. Alright, so we deleted 3 from fleets, so now we are going to, should be I equals 2 here. So 3, 2. Oh no, we're still here. Okay, so then 1. So that's the 0, 1 fleet, so this goes up, and this goes up. And now for I equals 2, so that's the second fleet, which is this one, that finishes. Okay, I equals 1. Okay, so this one will no longer move anymore. So we should also probably say, well, it's not in the dictionary, so I mean, just to be safe, I could say that finished of fleets of I plus 1. Alright, so those are both finished. False. So 1 is this one. 0 goes up. Still nothing finished. 1. Fleet 1 passed fleet 2. But isn't fleet 2 finished? So shouldn't this not execute? Fleet 0. Alright, I just have to print out the fleets as well. With I. I'll probably give this one a couple, like 10-ish more minutes. Alright. So fleet 2 passes fleet 3. So fleet 2 is at, I don't really want to do that. I guess I have to. Okay, so fleet 2 is at index 0. So this one passed fleet 3, which is at index 3. So my question is, fleet 1, okay, so fleet 1 is at index 2. So that's this one. Fleet 1 is at fleet 1 is at index 1. Past fleet 2. Fleet 2 is at index 0. So you're saying that this one passed that one. That's true. That's true. But isn't it finished already? Isn't fleet 2 finished already? So finished of... Oh, this is the problem. I had a typo there. Okay, so this is not going to work because of the assumptions above. So fleet index equals fleets of I. We have an index error. So what's our input here? 108053. Yeah. All right, I'm gonna call it here because I worked on this for like an hour. This definitely isn't the right way to do it for sure. For sure. Yeah, I think I could definitely benefit by looking at the solutions for the last 3. And maybe trying again, maybe just like in 1 or 2 videos, I can revisit these problems after looking at the solutions. But yeah, so that's today. Not every day is going to be like a big success or anything, so that's totally fine. And I think today was day 57, so I'll see you guys tomorrow for day 58.